Alright, for this problem I'm going to take a problem that we just did, that is a medium difficulty probability problem. I'm going to try to do it a different way. Several people are confused by the way I use choose notation. Namely, you choose one amount and you divide it by the total number of the sample space. Here I'm going to use a decision tree. Alright, decision trees are a handy way to do probability when you only have a few select decisions to make. When you have more than 3 decisions to make, it gets really tricky. But for this problem, what is the probability of drawing 2 cards of the same suit from the top of the deck? It's not that difficult. And I'm going to do the same thing that I've done in previous probability problems, where I'm going to single out a select suit. Alright, previously I've done hearts, today I'm going to do diamonds because I think they're a little easier to draw. And we start out with one choice. That is the first card. It can either be a diamond, or it can not be a diamond. And let's figure out the probability for each of those occurrences. Okay, in the first case, you're right to say that it's a quarter chance, but I want to write it as 13 over 52 so that we're clear that this is 13 different diamonds and 52 different cards. And the probability of it not being a diamond is 39 over 52. Because there are 39 non-diamond cards and 52 cards overall. Now we can make a second choice. Alright, the second choice, we also have 2 options. A diamond and not a diamond. Alright, the choice here, if it's a diamond, well, we've already picked 1 diamond out of the deck. So we now have 12 remaining. And we've also chosen 1 card out of the deck, so our sample space is 51. Now, we've picked a diamond out, so the number of non-diamond cards is the same as it is down here, 39. But the number of cards in the deck is diminished, which is 51. Now, similarly, here, we have chosen a non-diamond card. We have 2 options, either a diamond or a non-diamond. Now, for this choice, the probability is, well, there are still 13 diamonds left in the deck, so I'm going to write 13. We have drawn 1 card, so there are 51 cards left. Here, for this, we've already drawn 1 non-diamond. There were 39, so now there are 38 and 51. Now, these events are independent, so in order to calculate the probabilities, we multiply them together. So, in this case, where we get diamond, diamond. So let me write it as 2 diamonds. It's going to be 12 times 13, or actually 13 times 12, same thing, over 52 times 51. Which is equal to 156 over 2652. Here, which is 1 diamond, again, irrespective of order. If order mattered, we would be talking in permutations. Here we're using combinations. It's 13 times 39. Over the same denominator, 52 times 51, which equals 507 over that same 2652. Here we have a non-diamond and a diamond. That's a 1 diamond occurrence, which is 39 times 13. Same thing as before. Which is equal to 507 over 2652. I'll be calculating these in a moment. Here is the occurrence of there being no diamonds. So this is 0 diamonds, which is 39 times 38 over 52 times 51, which is 14 1482 over 2652. Now all of these equal 0.059. This one is 0.191. This one is 0.191. And this one is 0.559. All rounded to the third decimal place. And if you add all those up, you'll get a probability of 1, which should make sense. Now, if you've just watched the previous video and you saw that we got an answer somewhere around 20%, I would say, well, we've only done diamonds. So the probability of 2 diamonds is equal to 0.059. So the probability of 2 face cards, or two of the same suit, is going to be 4 times this, because there are 4 different suits. And 4 times 0.059 is, in fact, 23.5%, which is the same answer that we got before. It's also worth noting that the probability of getting 1 diamond is the sum of these two, which is 38%, and that's 55%. So it's all adding up to one big probability picture.